By the end of this lesson, you should be able to explain types of experimental errors. Use appropriate techniques to reduce errors. Can you give the reading measured by each instrument? When making measurements, we are using the markings calibrated for each device, and our measured quantity will read to the nearest mark on the device. Do you think your measurements are precise or accurate? Markings calibrated on measuring instruments always have some limit of precision. This limit is determined by the design and construction of the measuring instrument. No matter how carefully we measure, we can never obtain a result more precise than the limit of our measuring instrument. The limit of precision of a measuring instrument is half the smallest division of measurement the instrument is able to display. Thus, a meter ruler marked in millimeters has a limiting precision of half millimeter. Besides the limit of precision on the measuring instruments, we need to consider errors that may occur when a measurement is taken. If an error cannot be eliminated or reduced, then it must be considered as part of measurement. These errors are classified as either systematic errors or random errors. One source of systematic error could be due to an inappropriate choice of measuring instrument, for example, using a meter ruler to measure the thickness of a book. To reduce this error, the student could use a vernier caliper, which is more sensitive than a meter ruler. Would a reading taken with this balance be accurate? Why? No, the scale pointer does not read 0 when there is no mass on the pan. Would a reading taken with this ammeter be accurate? Why? The pointer of the ammeter does not read 0. This is another source of systematic error, which is known as zero error. To reduce systematic errors due to zero error, the instrument is adjusted so that the pointer points to 0 before making any measurement, or subtracting the final reading with the value of the zero error. Systematic errors can cause the measurement to be consistently higher or consistently lower than the true value. Increasing the number of measurements and finding the average cannot reduce the systematic error. What can you see from the results obtained by the students? Why do the students get 3 different readings for the same measurement? The students have taken the readings from different positions. How can you avoid error in this case? The correct position of the eye when taking a reading is when the line of sight is perpendicular to the scale. Do you think the readings will be the same? Why? No, because the students are in different positions. Whose reading is accurate? The reading from B. What is the reading on the ammeter? 0.1 amperes. What is parallax error? Parallax error occurs when the observer's line of sight is not perpendicular to the scale. How can you avoid parallax error in this case? To avoid parallax error in this case, the reading is taken when the eye is exactly in front of the pointer. That is, when the reflection of the pointer in the mirror is hidden behind it. Are the readings taken by different students the same? Why? No, they did not start their stopwatches exactly at the same time due to their different reaction times. Error can also be due to the different reaction time of different individuals. To reduce the error due to the reaction time, the student should start the oscillation first, followed by counting down before starting the stopwatch. When errors are unpredictable and vary from observation to observation, they are known as random errors. Random errors are due to human errors while doing the measurements, such as when reading the scale or when counting the number of oscillations. The fluctuations in the physical property being measured, such as changes in temperature, electrical voltage, gas pressure, etc. Random errors can be reduced by repeating measurements and finding the average.
Identify possible type of errors that the student may encounter. Complete this table.